right, good evening. How's everybody doing? Good. Good deal. I'm glad to see a nice big bunch of people in here tonight. Thank you very much for coming. My name is Terri Kirby Hathaway. I'm the Marine Education Specialist for North Carolina Sea Grant, and my job consists of working with educators from classroom educators as well as informal educators, people like at the aquariums and the museum, and we have people from the aquarium and the museum in here tonight, which is awesome to see. So I get to work with educators to get them more familiar with the ocean and how to use the ocean to teach all their subjects in their classroom if possible, and also just to have people learn more about the ocean. So I do a lot of outreach, I do a lot of family events, and then going in and we're doing teacher workshops. And this is one of my favorite things to do, is do this kind of presentation. So I see a few familiar faces, so you might have been to the one I did last year on beachcombing biology. This is a little more specific, and I actually learned a new word while I was doing a little more research for this presentation. Has anybody ever heard that word, ichnology? I had not heard that either until yesterday. So I thought, ooh, that's a good new title. And it's marine ichnology. So what ichnos is the Greek word for trace or footprint or tracks. So marine ichnology is the study of animal tracks and behaviors and remnants of their behavior. So that's what this whole story is going to be about, is the things that animals leave behind. It's really supposed to be a paleontology, looking at fossils and the tracks that you find, the fossil tracks that you find, but it does apply to looking at current animals too, not just fossilized or extinct animals. So, new word. There will be a test at the end of the talk, so make sure you remember what it's all about. So tracks and traces, okay? All right, and the reason I do this is I want you guys to become ocean literate citizens. Ocean literacy is an understanding of the ocean's influence on you and your influence on the ocean, because it goes both ways. As an ocean literate citizen, you guys should be able to understand and discuss the essential principles of ocean literacy, which I'll go over in just a minute. You should be able to communicate about the ocean in a meaningful way, and you should be able to make informed and responsible decisions about the ocean and its resources. And for those of us who live here, that's extremely important. So we need to reach everybody, and everybody, even way inland, needs to be ocean literate, because everybody votes on these things, not just the people who live on the coast. Oops. There's the essential principles of ocean literacy. Number one, there's one big ocean with many features. You know, we talk about ocean basins, but it's really all connected. And we used to think of oceans that divide countries, but really oceans unite everybody, because it's all circulating all around the world, one big ocean. The ocean and life in the ocean shape the Earth's features. Ocean is a major influence on weather and climate, especially people who live at the coast. You certainly know that. The ocean makes Earth habitable, and that's coming from the 50 to 80% of the oxygen that we breathe comes from ocean plants and phytoplankton. The ocean supports a big diversity of life and a lot of different ecosystems. The oceans and humans are inextricably interconnected. That's hard to say, inextricably interconnected, because we are. And the ocean is basically unexplored. We know more about the moon and Mars than we know about the deep ocean. How about that? It's crazy, isn't it? But that's the way it is. So beaches all over the world, they're all very different from one another, but there are a lot of similarities. Let's look at a few. There's a pretty beach on the big island of Hawaii, whether you're looking there or you're contemplating the vastness of the ocean on Ruby Beach in the state of Washington with the big rocks out there. How about a sunset on a Pacific beach near Monterey? Or Pink Beach, and if it were darker, you could see this is Pink Beach and Komodo Island National Park. The pink comes from little tiny animals called foraminifera. Or my beach at Southern Shores, North Carolina, which I go to a lot. Or this is one of my favorite beaches. Where's that one? North of Corolla in Corova, right. So it's called Wash Woods. I get fascinated by that beach every time I go, because those trees do not live on the beach. But they're a sign of the beaches, the barrier islands rolling backwards. So that used to be upland, and then it used to be the back side of the island, and now it's the front side of the island. But I just think that ghost forest is just fascinating. So the beaches all over, and there's all kinds of animal remnants, tracks, things on the beaches, no matter where you go. So let's start with the first one. You ever found these shells that have lots and lots and lots and lots of holes? Okay, now on every other table, I've got things. So I want you to look, when I talk about something, I want you to look at the things and then pass them down. They'll go down to the end of one row and back the next, and the next table will hold them for me, okay? So I've got hand lenses if you want to look close at them. But what in the world made all those holes? It looks like my husband got out there with this drill bit. Well, what made these nice holes is what's called a boring sponge. And it's not boring because it tells boring stories and you want to get up and leave, but it bores holes. It chemically etches holes into a shell or other hard surfaces, and that's for attachment, to anchor itself, to find a place to live. So it lives on shells. Now, it's not a predator. It's not a parasite. It doesn't get any nutrition from the animal that it's living on, but it does compete for settling surfaces with other animals, and it can grow large enough to encrust the whole shell and actually kill its host. But that's not what it doesn't do that intentionally like with a parasite. But it's a beautiful animal called a boring sponge. And it also, with it etching out the hard surfaces of corals and shells, is creating sediment. So it's adding something to the environment. All right, what is this one? See the holes all in there? What is that? Coral, very good up here on the front row. Coral, so coral is a colonial animal. Every hole you see, every cup, held one animal. So when you see a bunch of coral or a coral reef, think about the hundreds of thousands of individuals that it takes to make up that reef. So that's part of a reef on the top left. The other one has star coral that settled onto a quahog shell that has been bored by a boring sponge. So there's a lot of stories in that one shell on the right. So we call that's one of the holes. There's what a coral animal, there's a bunch of coral animals together. So yeah, is everybody passing the corals now? All right. Anybody ever seen these holes on the beach? See, there's a hole right there in the middle. There's a hole on either end. There's a hole right there. Found these on the beach with the holes? What in the world is this animal? I don't have this one, unfortunately, for you to pass around. The animal that makes this is a worm. It's called a plumed worm, and it lives in this tube right here. See, there's the hole on the top, and if you'll notice, the hole is not at the very end. It's not like facing up. So it's on the side. It's it's a lateral entry, and that way sediment won't get into it. It won't rain down from above, but it decorates using pieces of seaweed or shells, other detritus that it will find. It decorates. Part of it's camouflage. And if you see a bunch of these together, it looks like a bunch of little chimneys, little decorated chimneys. They stick out about anywhere from 3 to 6 inches out of the ground. And underneath the surface of the bottom, what's underneath is totally secreted by the worm. Now, it's neat because it will feed, it comes out of here and kind of ambushes its prey out of the side. So it'll ambush something that swims by, it'll grab it with the palps, those are its feeding tentacles. The other neat thing is it will feed off of other things that are attracted to the beautiful detritus that on its camouflage tube. So it'll eat little amphipods or other little animals, and then it might eat off its neighbor's tube too. So they live in a big neighborhood, so everybody feeds off of each other. So it's called a plumed worm. This is an interesting one that you may see. These are usually further south. I've never found one of these north of Cape Hatteras, but definitely in the southern part of the state and definitely all the way down into Florida. You see two of them, that's two chimneys, and that's a close-up of one. You see the hole right there. And if you find it washed up on the beach, that's what it looks like. So there's a hole on either end. So this is one tube right here, and it is shaped like a U. So there it is right there with the little chimney sticking up. So that is a parchment worm, another worm. And there's what the worm looks like. Kind of strange looking. This is the head down here. These are the paddles that they move those paddles back and forth, and that creates a current through that U-shaped tube. So, and then these are for respiration or gas exchange, so that's how it gets oxygen. But so this will start going, and it'll start the flow of water. It comes in by the head. There's a mucus netting right in here that captures all the food particles, and then it cuts the food particles, the pouch, off and moves it up to the head where then the animal can eat it. So it's got this tube going the current going this way, so food comes in, poop goes out. So they can clean their tube out by that water current that's going through there. It's called a parchment worm. Yeah.
What is that tube made of?
They make the tube. They secrete.
They excrete.
They secrete it's almost like kind of material almost, but you can tear it. But they secrete that tube. Yeah, I'm not sure which part of the worm secretes the tube. It's really kind of interesting. Different kind of worm. All right, next hole. Look at all the holes on here. You see the hole there, hole there, hole there, hole there, hole there. Holes all over on these shells. They're not part of the shell. And if everybody who's on the end with the table, if you turn over your sand dollar and or also called a keyhole urchin, they all have tubes on the bottom. Do you see those? So see if you can find the hole in there. So look at that. So that's what we're looking at is these tubes right here. They're calcareous tubes. And this is another worm. Worms leave a lot of evidence. A lot of evidence. So this one, okay, I got to get to the right worm because I'm talking about a bunch of different worms. These are serpulid worms. They have these calcareous tubes. There is just one opening at the end, and that's what that's what the worm looks like. So you can see the calcareous tube. And these are their tentacles that they feed with. Now, when they pull themselves in, because they have to, they don't always stay out looking like the Christmas trees or the pretty flowers that they look like when they're out. But when they pull themselves in, they have this, it looks like a golf tee almost. And they pull that in, that's their operculum. And you see that one's closed right there. So there's the golf tee closed. So they will filter feed with these tentacles, but they have to have a hard surface to settle on to make their home. So does everybody see that the tubes out there? Yeah, good. All right, so that's serpulid worms. Now let's go to another hole. Look at all that hole. That's a bunch of holes together. And unfortunately, I have only one example of this. So I'm going to start this up here. But this is called worm rock. It's done by mason worms. And it's sand worms, sand masons. They pull these, they have these little tubes like this, and they all cement together. And over time, they make rocks, worm rocks that you'll see. Now, these are reef builders in Florida. Really kind of interesting. Also, there's one opening. So what you can't see with this worm, and I think this is pretty neat, it has a long intestine extension back here, but it doubles back and lays on top of its body. So as it excretes, it puts the fecal pellets right outside, and they're too big to get caught on the feeding tentacles. Because, if you only got one entry, everything goes in, everything goes out the same way. But they have their fecal pellets and throw them out the door. Pretty cool. So that's a mason worm. All right. Now everybody should have a piece of a shell that has all these little markings in it. Have you ever found shells that have these lines in them? Yeah. What made those lines? A worm, yes. I should have titled this Worm Talk. Although there are other things. But yeah, so a worm makes this, and this little worm is called a palp worm. And they also secrete some acid that breaks away these areas so they can lay down in these little areas as for protection. But they also, this is the term bioerosion. So these things are being broken down by a biological being. So it's bioerosion instead of like physical erosion, like wind and rain. So bioerosion by the little palp worm. I think he's kind of cute. Let me see. All right. What about these holes? Ever see these holes on the beach? These are up above the tide line, above the high tide line, so in the dry sand. It could be one of two things. Neither of them is a worm. It could be an amphipod, which is an arthropod, and that's a jointed-legged animal. They're also called beach hoppers. You may see them up around the rack line. So a lot of them live in the rack line. Some of them live in these holes permanently or temporarily. But these are flattened from side to side. You know, isopods are the little roly-poly bugs. They're flattened from top to bottom. These guys are flattened from side to side. So that makes them amphipods instead of isopods. So it could be those, or it could be a tiger beetle. Tiger beetle females lay their eggs in these holes. Then the larval stages and the juveniles stay in the holes for a while, and they can ambush their prey from the holes. So it could be one of these two. There's no distinction between what the holes look like. So you just have to sit there and wait. You got a question back there? Okay. All right. These are some interesting holes that we all see on the beach, right? What are they? Barnacles, yeah. But there are two different kinds of barnacles. There are barnacles on stalks, and then there are barnacles that are not on stalks. So these are the flat barnacles, and everybody should have a barnacle piece to pass around too. So the barnacles have to settle on a hard surface, whether it's a shell, a piling, your boat, a horseshoe crab, whatever. They have to have a hard surface, and these are the ones that do not have stalks. These are calcareous plates, and what's missing right here, why you have a hole there, is because there are 4 plates that are missing. 4 plates serve as the door, like the garage door. So when the animal dies, those fall away, and you're left with these plates that are cemented together. So there's a barnacle. Now, when a barnacle starts out life, we're going to do a little life history lesson. This is what it looks like. Isn't that the cutest thing? So Nauplius larvae. It's got a little red eye right there. And then it grows a little bit, and it turns into this. That is a cypress larval stage. And then it settles down, and then it looks like this. Now, it's a Cirripedia is the family name, and that translates into feathery feet. See how it got its name? Because those are its feet. It feeds with its feet. Aren't you glad we don't feed with our feet? But it has feathery feet, and it collects the plankton out of the water. You have a question?
Yes. At first it looks like a tick.
It looks like a tank?
A tick.
A tick. Oh. Yeah, these are much prettier than ticks, though. Don't you think? Yeah, I think so. All right. Yeah, it does look like a tick, but not anymore. That doesn't look like a tick, does it? No.
Way prettier.
Way prettier, yeah. How about these holes? You ever seen these holes with the chocolate sprinkles around them? There's the hole. Look at the chocolate sprinkles. If anybody really thinks these are chocolate sprinkles, do not make me cupcakes. This is not a worm. What is this animal that makes this hole? Anybody? A what?
Shrimp.
A shrimp. It is a shrimp. Look at that. It's called a ghost shrimp. But it's more related to hermit crabs than it is to true shrimp. But that's what the animal looks like. All right, and you saw this one hole. These are three tubes right here. Look at the intricate maze. So there's always more than one entrance to this one. These tubes can go 6 feet down. So can you imagine this little thing making this? Somebody who was studying these took plaster of Paris and poured them down into a hole and let it harden, and then they could pull it up and see what the structure of the tunnels looked like. It's pretty amazing. They use this back part, these back appendages, to create that current, like we were talking about with the parchment worm, because they've got to have water moving through here for gas exchange, for cleaning, and for feeding. That's pretty amazing. The ghost shrimp. What is this one? Very familiar. Ghost crab, yes. The ghost crab. This is a small one. This is a big one. Look at that mound with all those tracks. That poor hermit crab had come out of that hole many times. Bringing all this, uncovering it, because it usually gets covered during high tide. And then when the tide goes out, if they're below that high tide line, they got to come dig out, bring everything out, and then feed. So yeah, the ghost crab, that's what it looks like. Scientific name is Occipita quadrata. And occipita translates into swift-footed, and quadrata is square. So you see how square it is. So it's a fast-running, squared animal. It's amazing how they get these names. If you know your Latin and your Greek roots, you can kind of tell how it got its name. This has the reputation of being one of the fastest invertebrates on land. It can go from like 3 to 5 miles per hour on a deck of a boat. It's pretty good for something so little. These are nocturnal feeders. They're scavengers. They eat, dead things on the beach. They will eat peanut butter and jelly sandwiches. They will eat sea turtle hatchlings, unfortunately. But these are scavengers. They live in those tubes, the tunnels up away from the water, but they have not made the break. They're not terrestrial animals. They still have to keep their gills moist. So sometimes at night, if you study them, you can watch them go down to the edge of the ocean and get wet. So they're wetting their gills so they can keep them moist. Sometimes the tunnel has enough water in it or moisture in it that they can stay moist enough that way. Now their tunnel is at a 45-degree angle, only one entry, so it's an entry-exit. Goes down 45 degrees, and it goes into a big area that's a turnaround area. So they can't go down and come back out. They have to go down and turn around and come back out. They either lead with the right side or the left side. They're not ambidextrous, unfortunately. But I have to show you this because I think this is one of the cutest pictures ever. That's a baby ghost crab, a juvenile ghost crab, and it is bright blue. Can't tell with the light in here, but this is bright blue. And this is right before he's just come out of the plankton stage, and he's down on you see how tiny he is. Look at those big, large grains of sand. This was taken up in Kerala. But isn't that the cutest thing? Baby pictures, we love them. Okay, if you found these, I've got one piece of this driftwood that we'll pass around. What made these holes? Well, that's a good guess. She said a worm. That's a really good guess. And it's called a shipworm, but it's not a worm. It's actually a mollusk. And if you look, it says there's the 2 shells. It's a 2-shelled mollusk, just like a clam or an oyster. But it's got 2 shells right here on the end, and that's what it uses to dig the wood out, to bury in these holes. It digs through the wood. And at the other end, it's got 2 siphons that it can take water in and squirt water out. But you can see the lining in the holes. They line it so that they can slip through these holes easily. So as they're digging in, they line the holes with this lime substance. Now, the other neat thing about these, about termites have that cellulose digesting bacteria in their gut. So they can't digest the wood that they eat of our houses. These guys can't digest this wood either. They have the same type of cellulose digesting bacteria in their gut. So that's how they get their nutrition, is somebody else is digesting it for them. So shipworm, not a worm. Called a worm, not a worm. All right, what made these holes? And everybody's got these, and everybody should have one of these to pass around. So one drill bit, not a bunch of them. Yeah, so we're going to do a little CSI, not Coastal Studies Institute, but crime scenes investigation. We'll see who did it. The moon snail or the oyster drill. One of these two. So they make a hole. They're hungry, time to eat. They go for a clam. This is a Venus. This is a crosshatch lucine, but a bivalve. And then they spit first. They've got really good spit. And it starts dissolving the shell. So they've got this spit going on, and then they've got this radula, which is looks like a drill bit. It's like a tongue covered with teeth. It's called a radula. And so then they start drilling, and they spit and drill, spit and drill, spit and drill, until they can get in and eat the animal on the inside.
Does it rotate or just pressure?
Both. It's a little bit of both. I don't think it rotates all the way around. It would just kind of back and forth. But it's really kind of interesting that they have something like that they can drill inside a shell. Have you ever tried to drill a shell? Next time, spit on it first and see if that helps. Oh, everybody found these holes, right? What are these? This has two things that goes along with it. So this is the egg case for the whelk. And if you open one of those, or if you see these holes are plugged sometimes when you find them, or they may be open. But what comes out are tiny little baby whelks, and then there's an adult extruding the egg case. So there is internal fertilization. So there are separate males and females. Internal fertilization. The female takes the fertilized eggs and passes them through a capsule gland, which places the capsule around it. And then she attaches it somehow, it's all magic to me. Attaches it to there's a line, so they're all attached together, and then she keeps extruding it until it's done. And I don't know how many, it just depends. These have different numbers of capsules on them. But isn't that amazing that they do that? Now, and we have 3 species of whelks here in North Carolina, and this is the knobbed whelk, so it opens on the right, and I didn't bring any whelks with me. The lightning whelk opens on the left. The channeled whelk opens on the right, but has a channel around the top. Each of the species has different shaped capsules, so you can know which species laid the egg case that you find. Very interesting. So, as I mentioned, this is plugged when it first comes out. As the eggs develop in the capsule, the babies inside will eat that plug out so that they can crawl out and hatch or escape or whatever you want to call it, but they can get out. Kind of interesting. Nature is amazing. Here's another hole for you. There you go. This should have one of these to pass around. Yes?
Okay, we're okay.
Yeah.
We're okay.
All right, you can talk to me afterwards. You ask me all the questions you want afterwards, okay? Yes? Yes, ma'am. Okay. Nobody really knows that I've been able to find. Yeah, how long does it take from the tiny baby, from this stage right here to adult? If you look at the animal, if you look at the shell, you can see that there are lines added to it because it adds to that shell all the time as it's growing. And some of the lines are close together, so that was a very short growing season. Some are farther apart. Long growing, they grew a lot during that time. Unless you raise it from a pup, you really don't know how long it takes. So that's a good question. I've never been able to find the answer to that. I still look. All right, so let's go. This is called a Keyhole Limpet. These are really pretty. You notice the keyhole is a little offset from the center. Water goes underneath the shell. So it's kind of like a snail carrying this one house on its back. Water goes underneath the shell, and it passes over the gills for gas exchange and for food, and then it comes out the hole. So that's an exit hole, not an entrance hole. So we have several different kinds of limpets in North Carolina. And here's another good one that everybody knows. It has the holes. These holes are called lunules. So I like to call this a keyhole urchin because of the holes, but a lot of people call these sand dollars. I usually don't find dollars. I find sand quarters. That's what I find. But anyway, these holes serve a couple of purposes. It helps move food. Now, this is one that has been recently dead because you can see it's kind of fuzzy. This is one that's been dead for a while and has been bleached. It's got tiny little spines all over it. So the mouth is on the underside, so if there's any food up here, they've got to move it around or through the hole into the mouth. So the little spines help move that through the holes. This also helps them burrow because they like to hide just below the surface. So sand comes up through these holes as it's burrowing down. And it also helps with the hydrodynamic lift. If the water comes, big current comes along, it helps it stay below the surface. The water can't get under it because it'll come out those holes. It won't flip it over. So they serve a purpose. What is this one? Everybody's got a piece of this to pass around. See that plastic bottle? What made those holes? Not a worm. Any guesses? Turtle, that's right. Very good. Sea turtles. If you look at the sea turtle beak, when it bites down, it takes a diamond shape out of it. So turtles, not the sharpest knife in the drawer, but they've lasted a long time. They've been around for a long time. But they're, I'm hungry, here's something floating by. It might be a jellyfish I'm going to eat, take a bite and see. Oh, that's terrible. I'm not going to eat that anymore. But hopefully they spit it out and they don't ingest much of it. So, yes, that's why we don't like plastic in the ocean. Plastic bags look like jellies. These guys look like all kinds of stuff to a turtle. So, so turtles, gotta love them though. All right, some interesting holes. These are usually down between the high and low tide lines. And I'm not talking about this one, I'm talking about all these little pinprick holes. And you see these that look like mounds? They're kind of mounded, but if you step on them, they're hollow underneath. What creates those holes? Well, if you look at them from the side, this is what they look like. They call these are called volcanoes, these are pits, and these are nail holes. That's what Orrin Pilkey calls them. But looks like volcanoes. What happens as the tide recedes, where water used to be in and around all the sand grains, it dries out because the water's gone. So it dries out and leaves a bunch of air spaces. So as the tide comes back in, I know you've seen this, tide's coming in, you look at all these bubbles coming up out of the sand. This is where they're coming from, these holes, because water's going in there and filling up the empty spaces again, and it got to displace the air out of it. So they're basically air holes. So no animal. So this is not really ichnology because there's no animal traces. But it's a phenomenon that I think is pretty cool. Oh, this is a big hole. Look at that. See the hole there? Hole there? Who did that? Lightning did that. These are fulgurites. Fulgur is the Latin word for lightning. It's when the lightning strikes the dry sand and the heat from the lightning fuses the silica grains together. And this is still considered one of the largest. It was documented by the Smithsonian. This is in the Nellie Myrtle Prism Beachcombing Museum collection. And Nell found this in 1945 and I don't know when she called the Smithsonian, but she got the Smithsonian down to look at it, and they said it's the largest one they had ever seen. She didn't give it to them. She kept it for herself and to share with all of us when you get to go to the Nellie Myrtle Prism Beachcombing Museum. How big is that, Dorothy? About like that? About that big? Yeah. It's impressive. Yeah, and when you look at it and see that, that's just looks like pure glass. It's pretty amazing. This is one from Jockey's Ridge. So you can see the hole in there. And then I've got a couple in this. These are fulgurites. They're tiny, tiny. They came from underneath the electric lines that went across Jockey's Ridge. So that much electricity escaped those lines. And those lines are not there anymore. They removed the electric lines from Jockey's Ridge. But a friend of mine worked there and told me, he said, come on, let's go find some. So he took me there. And they're just like tiny little fulgurites, but they're tiny, tiny compared to these other ones. And then if you go up in the Kerala area, you'll find these kind of this one's got holes at either end. These are wet sand fulgurites, where when the lightning hits dry sand, it goes straight down. When the lightning hits wet sand, it spreads out. So these are usually flat or round, and then they've washed around in the swash zone for a while. So we have wet sand fulgurites and dry sand fulgurites. All right. And that's all my stories of the holes on the beach. I hope you've enjoyed it and learned some new things. Maybe you discovered some answers to some mysteries that you had. I do have a handout of references, all of the ones. These are my favorites that I brought in, so if you want to learn anything more. Bookmarks for you to take with you. I'm available for questions. I have my cards here. You can email me, call me. If you find neat stuff on the beach, call me up, email me, send me a picture. I can help you figure out what it is. And I want to thank you all for you coming tonight. Now, who's got questions? I know you got questions. I know you got questions. You got questions, don't you? Can we talk afterwards? Can we do that? Okay, good. All right, anybody else have questions about anything? Mystery solved? Yeah. Hang on, we're gonna, if you talk in there, because we are streaming live, so we can have the audience in what used to be television land is now internet world, so they can hear you.
Barnacles you can find on a horseshoe crab or a pilot, are they the same barnacles that you see on whale?
No, the ones that are on whales, they look the same, but they're different. The ones that are on whales are specific to whales. You would not find the ones on the whales. You won't find them on any other animal or any other thing. But they're a lot of different species. So it would be. That's a good question.
Thank you.
Excellent question about the same barnacles that we find on our pilings the same ones you find on the whales? But no, and the turtles the same thing, different ones. Question in the back there, Kent. And then Sophie, we'll get to you.
Didn't have the question then. Mary, I am in the process of bringing together a lot of shells that have been given to me. Would you like the box of shells?
Oh, man. I would love a box of shells.
Okay.
But if you don't mind, what I do with them when people give them to me, I fix little goodie bags to send to teachers around the country.
That would be
What
okay? I would like you to do with it.
All right, yeah, I'll take them off your hands.
Okay.
Thank you.
I'll pick your card up.
I like that question. Sophie, did you have a question? We got to do Kent right here. Come this way. To Sophie.
Wondering, the sea fleas, do they bubble up or make any, how they like dig down in the sand?
The which ones?
The little sea fleas or?
Oh, the mole crabs?
There you go.
Yeah, yeah. No, they don't because they're usually burrowing in wet sand. So you know how wet sand is real fluid?
So they're not bubbling?
No, you wouldn't see them. Yeah, you wouldn't see them bubbling. Not that I know of. Question right there, Kemp.
This is a little off topic, but I've
I
seen
love it.
several things on the beach that are light, like coal, but rounded, like they've been beat up in the surf for a long time. Is that perhaps coal from shipwrecks? What is that? Do you
It
have
may
any
be
clue?
pumice. I don't know. I haven't seen any. So I've got a piece that I collected in Florida. But pumice is like, magma that has come out of the earth surface center and is cooled. And it hadn't filled in, so it's real light when it dries and it floats. Has it floated? Did you try to float any of it? I haven't tried it. I should try to see if it'll float, because that'd be neat. But you can pick up pumice on the beach. And it's not from Hawaii. Don't get excited. But that's the and coal probably. I don't know if coal would float or not. Coal would not float. Okay. The director's telling me coal would not float. Okay. Anybody else have questions? Well, again, thank you very much for your time and attention tonight. I'll be up here if you got questions you didn't want to ask in front of the group. Come on up. I don't mind. So thanks again.